All right, welcome back to Tonedevil Guitars. This is Anthony Powell with my brother Dave Powell here, and we're excited to announce the collaboration effort that we are in with Jamie Dupuis, the YouTube sensation, professional harp guitarist, and wonderful musician extraordinaire. We've got a collaboration effort going with him to construct a brand new model of harp guitar. He's been very well known for using our 18-stringed harp guitar, and he has asked us to produce a new instrument for him for the use of some classical music that he's going to be doing and some other various music, and we'll be adding a string. Is that right?
So it'll be 19 string, basically the same configuration, 6 bass strings, 6 guitar strings, all nylon string with 7 trebles this time. He just wanted to have a little bit more melodic options up there. Yeah. And we'll be guiding you through the process. This video will actually show pretty much the entire process. You can see now I'm blocking up the neck stock onto the deck so that I can get the CNC ready to carve it out, which is what I'm doing there.
And we're actually cataloging the entire build of Jamie Dupuis' harp guitar. So this is all, this entire video is all Jamie Dupuis' instrument being constructed from scratch using blocks of wood, as you can see, like that Dave was just saying. This is the neck block that's been constructed out of a bunch of kaya, or otherwise known as African mahogany. And here's the roughing pass. Tell us a little bit about that.
Yeah, this roughing pass is just probably one of the most brutal shrapnel producing passes you could do on the CNC machine. It uses a 1/2-inch bit that you can see is sticking out almost 4 inches. It sticks out just over 3.5 inches, and it
sticks out of the CNC machine.
The collet, out of the head of the CNC machine.
It's a very long bit.
The bit itself, overall length, is probably about 6 inches long. Wow. But you really have to get down deep. You can see as it gets up close to the heel, it has to cut all the way down to the length of the heel, which is 3.5 inches deep. And you can see it just really ripping through that mahogany pretty good.
Using a bit that size really does put the CNC machine through its most rigorous, uses. Most of the time, people use CNC machines to carve, flat things, but this is a very three-dimensional thing, a guitar neck, and so you can see how it's producing the, guitar neck shape and profiles using the technology there, and this is a nylon string instrument, so it's going to have a classical guitar peg head with slotted peg head tuner holes, and I'll be
cutting those tuner slots here in a second. Right now it's just kind of doing final contouring of the heel. And you see it kind of only goes in one direction, and that's because that's just the direction that the bit spins.
And then the grain, you got to worry about the grain, the direction of the grain according to the bit rotation. And so Dave's got a lot of hard work into these tool paths.
Yeah, it's a little bit time consuming to come up with them, and I'm sometimes experiment on the directions and how deep you can cut, and you just always want to be safe and take off less material. More passes, less material is always safer and easier on the machine as well. But you can see here you also need that really deep bit to carve all the way through that peg head there.
Getting those slots for the slotted peg head tuners.
So here's the final profile pass of the neck of the roughing pass. So it's going to cut all the way through down to the deck there.
Dave's vacuuming up some of that beautiful mahogany chips that I like to use in the smoker later for my brisket or some smoked salmon or something.
We like to use those hardwood chips for doing meats and.
So that was the roughing pass. So you can see it's a little rough. It's got showing a little bit of signs of a dull bit there.
Yeah, there's some tear out. That shrapnel off there is kind of a telltale sign. I need to get that bit sharpened. Probably get a new bit. Get that one sharpened. But so the fine pass will pretty much take care of most of that. This is a ball nose. That last one was just a flat end mill bit. This is a ball nose, so it's just a 1/2-inch radius on the bottom of that bit, and it's also a spiral cutter.
So this pass is taking off very little material, like maybe a 1/16 of an inch or something. Maybe
32nd, almost about a 32nd.
Yeah, so it doesn't have a lot of work to do on the blades of the bit, on the flutes, and so it takes a real fine pass and turns this blocky looking thing into a really beautiful
smooth guitar neck. Yeah, it's always nice to watch this pass because it really takes the most shape here, and it's just kind of appealing to watch it. But yeah, you want to have a bit that has a real wide radius for the tip of it. The wider the radius, the flatter the cut and the less tool path, which
So
is
that's
called...
what you mean by a ball nose bit. That means it's got a rounded tip.
Yeah, it's a spherical tip. It's ball-nosed. There's flat end mill, ball-nose end mill. There's bull-nose end mill, which is flat with radiused corners.
Oh.
But for doing this type of carving, you pretty much want to use that ball-nose bit.
And there's Dave's
Cleaning up the spare
all
stuff.
That beautiful meat smoking wood.
Mahogany makes good smoke wood. Walnut makes really good smoking wood.
Yeah. So we're just about getting done with this
Looks like
CNC
that's it.
guitar neck.
Yep, there's a finished profiled neck. Everything looks pretty good off that. I'll have to just do a little bit of prepping now to get it ready to go in the rim. It'll need to get the front of it cut off. But it looks like we're going to do some side bending first.
So yeah, the original instrument that we built for Jamie, the 18-string harp guitar, which we have modeled in NST, which means nylon with super trebles, was built out of black walnut.
Yeah.
So we changed the back and sides tone wood for this build for him to give it a little bit sweeter and richer of a sound. The walnut has a little more projection, but the mahogany, I think, has a little bit warmer sound to it. So overall, mahogany is going to be a really beautiful matched wood with his western red cedar top. And so Dave's bending some mahogany for his side rim.
You can see the harp arm side got bent. I think I misaligned it there, so I had to kind of look at it again and get it aligned. But yeah, doesn't take too long to do the bending. Those blankets get really hot. Those heat blankets get very hot. So
about what temperature do you think you're bending this mahogany at there?
This one's well over 300 degrees. It's probably 350 or something. This blanket doesn't get as hot, so it takes me a little bit longer in here. So you're kind of seeing the end of the job.
This blanket, this heating blanket, you can see that orange material underneath the wood there. The wood that's being bent is about 4 feet long, isn't it? So that requires a lot of watts to heat that sucker up to.
Yeah, I think we actually just replaced this blanket. It's not high enough wattage, but it did work for all this time. You got to take your time with it and go slow, and then you also have to cook the wood a little bit longer. It's almost like you're a chef or a baker when you're doing this process, because you have to laminate it down really thin. Then you got to cook the wood. You got to bend it in there with some moisture and make sure there's the right amount of moisture and steam and stuff and heat.
You really are a baker, aren't you? When you're
it's kind of wood baking.
Look, the pie's coming out of the oven right here.
Yep, and it's all done. It cooled down. All the oil's solidified, and it will hold that shape.
That's a real nice bend right there. Nice waist bout, nice lower bout.
Yep, looks like it bent just fine. It's holding the bend.
There's the inside harp arm there, that small piece, and now Dave's taken out the treble side of the rim.
That one usually always bends nice because that heat blanket heats up real hot. So yeah, they're done with the side bending. Now we do a dry fit onto the mold, so it kind of gets sort of clamped in on the waist, and the harp arm gets clamped in, and then we can do our alignment to it and kind of start getting the rest of the pieces.
I think back when we originally built Jamie's instrument, we used a stick frame mold, what we call it, and this is now an interior mold. So we have some boards of melamine that have been cut out to the interior shape of the harp guitar. So now Dave's getting that neck prepped up so we can integrate it into the rim.
Making sure it's straight there. I like to let them set on that piece of melamine there overnight after I cut the rough pass and the fine pass, because you do take off an awful lot of material, and that can release moisture or expose moisture that's deeper into the wood.
That's my favorite tool of the shop right there, this table saw. I got to interrupt you and mention that.
The table saw, yeah.
It was a 1925. The company that built that table saw went out of business in 1925, and it did come with the shop, and Dave did use it to cut the scarf joint out of Jamie Dupuis' harp guitar neck.
Tone's now drilling the tuner holes for the slotted peg head. Got that nice little jig. We kind of use a jig with a drill press. It just keeps those holes dead center aligned. This is one of those jobs that you want to make sure is exactly positioned right. Otherwise, those tuners, they bind up in there and they're not aligned properly. So this is kind of the surefire way to do it. Just make sure you get them nice and aligned.
I'm using a milling deck which has a X and Y axis adjustments on it, so that I can get real precise holes. for the slotted peg head tuners.
You can saw you had the tape that measured the depth on that bit there too, so you don't go down too deep.
Yeah.
Dave is now, let's see, what am I doing? I'm drawing a center line for the truss rod. So I kind of just draw myself a center line. I clamp it into this jig that we've built that just holds the neck in real tight. And this is actually on the CNC machine again, so I'm going to clamp this whole contraption, if you will, to the CNC deck now. And use my router bit and route out this truss rod slot.
Yeah, I used to use this same jig and route the truss rod slot with a plunge router, and now Dave is using it on the CNC machine, so it's good double use or continued use of this same jig. And I think Dave does a much better job with the CNC machine. He's able to get a tapered slot so that the truss rod actually has a little bit more functionality. And I think we're using double action truss rods now, so we can take radius, we can take relief out of the fingerboard, or we can put relief in. So either way, the lifespan of this instrument should be very well adjustable for the string action.
So now I've got it aligned, I've got it centered. I'm just going to go ahead and route the channel in about 3 or 4 passes. I take off about, 3.5 millimeters per pass. That's with a 1/4 inch bit.
Wow.
So 1/4 inch bit, there's not much sticking out. You can hog off quite a bit of material there. There's a little bit there at the heel where I need to widen the slot because the truss rods are barely wider down there at the heel.
Oh, so you actually do that using the same bit?
Same bit. I just kind of nudge the X over and clear it out, and nudge it over the other direction and clear it out.
Well, I've noticed because I think that it's 3/16 of an inch for the truss rod, and then it's a 1/4 inch for that little.
I think it's a 1/4 inch deep, and then about 3/8 depth. 1/4 inch wide, 3/8 inch.
And
deep.
then the width of the truss rod, those 3/16 inch wide. So you're using a 3/16 inch bit.
Yeah.
Okay,
this one, yeah.
Because the truss rod,
wide.
that little anchor at the very end of it where you adjust it.
There's a little weld on there that's wider
it's
usually.
A little wider.
And I'm testing the truss rod, make sure it works, which it does. And now Tone's going to go ahead and get the rest of the neck finished, sanded, and prepped. You got to do all the sanding out that tool path that the CNC machine leaves on there. You can't really see it in the video, but there's little lines where that ball nose bit, left. I think those are called, they're not scallops. They're called, there's a word for them. I'll think of it in a second.
Anyway, there's a lot of finish sanding that goes into each part of the harp guitar. I do some orbital sanding with about 100 grit sandpaper to take out all those tooling marks, and the CNC machine leaves it very smooth, but it all needs some finish sanding. I take our harp guitars up to about a 220 grit sandpaper on the whole thing, so the initial sanding of the neck is with 100 grit so that we can get it kind of smoothed out.
There you're seeing the neck heel template, which marks where the sides are going to get slotted into that neck heel. And Tone takes it to the bandsaw and cuts those slots just square to the top. And it takes about 2 passes, 2 blade widths, about the right thickness there.
Yeah, I've cut about 250 of those now. Gotten down to a science.
Still trying to think of that word. That's
it's a very technical
very
CNC.
Technical. It's a
CNC.
It's a 3D modeling term, for cam work and 3D cam work.
So now I'm going to be cutting in the neck top notch, where the top will seat down into the neck block. So we've come up with a couple terms for our harp guitars with the Spanish heel, one being the neck top notch and the other being the top neck notch. So a little bit of terms to be confused by, but it definitely builds it. The design really makes for a nice solid connection between the neck and the body of an instrument. Yeah. We've always preferred that to the traditional dovetail of modern steel string instruments.
I think I remembered cusps. That's what those are called. Little cusps between the drill bit, the router bit passes, or the little cusps. Okay, so now it's getting.
You were on the cusp of thinking of that word.
I was on the cusp of thinking of the word cusp. That's right. So it looks like we did the dry fit there, but Dave is now going to have to. I forgot. We need a harp head block. a harp head with the harp head block. So I'm cutting that out of this nice high-density Baltic birch plywood. This is probably some of the most high-quality plywood you can buy on the market. Comes in 5x5 sheets. And
all solid hardwood, maple.
Birch.
Baltic birch, rather.
Baltic birch.
Yeah. It looks a
yeah.
lot like maple.
It looks kind of like maple, yeah, but it's that birch ply. And it's just really high-quality stuff. We sort of deemed it quality enough to be on the exterior of a guitar. Technically, on our instruments, you can see the lamination around the harp head. We don't hide that.
There is binding on the edge up there to about halfway around.
It's partially bound around there, which hides some of those layers, but you know, it's high density enough. There's no gaps or anything. It's really good stuff. I like seeing that up there. We just, if you have just the hardwood like you were talking about before, it can tend to warp under the string tension. Those harp heads, because it's kind of a big wide surface. It can, with all the string tension, those do have a tendency to warp if it's not.
Yeah,
applied.
exactly. The shape of the harp peg head. It's hard to orient the grain of a hardwood solid slab in order to not warp. Plus, there's a headstock veneer that goes on there, which then contorts the shrinking and expanding of the wood over time. So we found out that just using this Baltic birch plywood solved all the problems, provided a lot of structural integrity to the peg head, which is under a lot of tension. I mean, there's 6 bass strings on there that are tuned up to about 23 pounds of pressure per string. So you can imagine the kind of pressure that thing is under for the lifespan of it.
Here's your favorite tool again, the nice big table saw. That blade can come out of there like 4.5 inches or something.
Yeah, this table saw is awesome. It can have a 15-inch blade on it, so it can extrude out of there by, like Dave said,
it's
5
got
inches.
A big 3-phase motor on it. So we're cutting the block for the harp head heel. So I can kind of just trimming it up there. But we were talking before about how this board was sold to us as 8/4, even though it's technically 10/4. It's over 2 inches thick and works really great for these heel blocks.
Pretty rare to find some African mahogany to be sold at 10/4, but we found that a couple of boards we bought from our hardwood supplier in Spokane. And here's Dave orienting the grain.
I think I got it oriented the right way.
Yeah, it looked like you started off
cross grain,
cutting it cross grain, and I corrected you there. But yeah, so we've modified the style of our headstock a little bit over the years. This angle that Dave just cut into there, which allows you a little bit of space behind the block there and the tuner peg to tune the strings. That's basically what that angle is that he's cutting in there. We used to do a big curve, and it was a time-consuming thing to construct, and it was also difficult to sand and finish and everything. So we just went with a straight angled cut on that. So Dave's about to glue up the harp head heel block. And Dave's found a very interesting way to spread that glue out without using his really expensive glue spreader. Otherwise known as the human finger.
Oh, yeah.
They still haven't come up with a better tool to use than the human finger to spread glue around.
Right. Yeah, 4 clamps on that, get all those corners. It's kind of tough because there's that angled cut in there, so you just got to get as close as you can on that. But yeah, that cuts it in nice.
Being it's under so much tension, it's important to get a real good solid glue joint on there.
So this must be the next day. The glue is dry. I can take the clamps off.
That's about the size of most of our days, is installing and deinstalling clamps.
Yeah, it's really the fun part, because it's like, I always say it's like Christmas morning. It's like you're unwrapping a gift, sort of. You get to take the clamps off. It's been like that ever since the beginning. I remember the first couple harp guitars, like, ooh, get to go out and take the clamps off in the garage.
Yeah, and see how things worked, and see if it glued up nicely, and see if sand those joints, and see how smooth.
See how clean the joint was. Yeah. See how tight you fit. You got it.
Yeah. Yeah, there's definitely a appeal to woodworking. Looks like that blade is getting a little bit dull there, but it's working nicely.
I don't quite have the guide down low enough either there, but
works good for this video. Now we can see exactly what you're doing. But so also what Dave's doing right now is cutting the side inlet channels, so that because the rim, the side rim of the harp arm will attach to the head block up there, and it will be recessed into the head block with those little channels. And he uses the CNC machine to actually give us some marks to cut on the bandsaw. So it looks like he's orientating the side rim and getting the neck and the harp head block ready to.
I just need to mark that treble side, where to cut it for the neck to fit in there. So you can see I'm using that little neck template. I marked the edge of the side right there. And then we're dry fitting the harp head in there. We're going to dry fit that and mark the harp arm and the inside harp arm.
And here's the tricky part with this new design we came up with a few years ago for Jamie Dupuis' super treble instrument, the 18-stringed harp guitar, that what we are calling the super treble tuner pocket. It could also be a shelf of some kind. And it's a real interesting design. Other luthiers have used different methods to build super treble instruments by adding a piece of hardwood onto the outside of the instrument. We thought that it would be better and more aesthetic to just integrate that into the body. So this is something that Dave's going to be building here in the next few scenes.
Right now I'm just marking those spots and marking the line on there. I'm going to trim all that stuff in so we can get a good dry fit. But you'll see me cut this treble side right there where I'm marking, right in the middle of the lower bout. It's like, wow, I'm going to cut the lower bout off this guitar.
You just bent this really nice side. Now you're going to just cut it in half.
I'm going to cut it in half. But we're going to trim up the harp arm.
And
side.
you always have to cut those square to the top side.
Right. You'll notice they have to go down. The side down is the top. So there I just cut the lower bout off of that thing. And I'm going to reuse that piece you'll see in a little bit. It'll get reused for the inside pocket of the harp, of the side rim there, the treble pocket. So now we're doing a little bit more of a dry fitting. Yeah, these ones with the super trebles, they take quite a bit more dry fitting.
It's a significant addition to this instrument. The harp guitar is already a very custom instrument by nature, and it's unique and asymmetrical and very difficult to build compared to a six-string guitar. But adding that super treble bank of strings on there with that whole tuner pocket basically is adding an entire third instrument onto the instrument. We've got the bass strings, which is kind of one instrument. We've got the six-string guitar, which is a second instrument. And now with that, what I would call like a Celtic zither, basically built onto the treble side of the instrument. It's a very meticulous design to construct.
And that's why this model costs more. We were pretty thrilled to be one of the first companies to really offer an affordable American-made, all solid wood, production line harp guitar. When we first got going full time back in 2010, and it was great because our S12 really fit that bill. We found some nice Engelmann spruce locally.
Yeah, it really set the stage for the market of harp guitar.
Yeah, it started appealing to that market, but then obviously when you get into the harp guitar market, as we've found out, that it becomes much more custom the further along we went. And we do these variations, additional strings, cutaways, sharpening levers, microtonal, multi-scale.
Added string, extra, even more strings.
More strings, yeah.
I think the most we've put on an instrument so far is 23. And
23.
That had 10 super trebles. It had a microtonal fretboard, so it was kind of an Eastern style music design, designed for more Eastern style music. And it was quite the feat. We had to enlarge the body of it in order to house the 10 super trebles. So with our modern design, or our normal classical harp guitar design, we can fit 6 or 7. And this particular instrument for Jamie is going to have 7 super trebles. So we're really ecstatic and excited to see what he's going to be doing with this instrument, and I'm sure you all are as well.
So right now I'm making the 2 tail blocks. One of them you can see is sort of an L shape there. That's the actual tail block. I added an extra lamination to make it about an inch deep there, and that's going to be where that tuner pocket is going to recess into the side. But I need to kind of block it up. I put a couple little laminations of walnut veneer over top of that plywood, so you won't see the plywood there. It gets covered. The exposed side will be walnut. And then both sides get that, and I'll be dry fitting it here, and after I get that all glued up.
And probably into the next day when they are
completely dry. Next day. Yep. The glue usually sets up in about 3 or 4 hours, safe enough to where you can take the clamps off. We like to leave them overnight, but some of the jobs, if we're in a hurry, we can do them the same day.
And it really depends on the glue joint. The top to the rim or the back to the rim glue joint is something that you kind of have to leave extra time for the glue to cure completely, because there's actually some tension on that joint. Yeah. So something like this, there's really no tension between that veneer and the plywood that you glued it to. So
you could unglue it right. You could unclamp it the same day.
After a couple hours, yeah.
Now, you see this is that extra side I cut off of the treble side, the lower bout of the treble side. I'm rebending and repurposing that and bending it into the new shape that's going to be inside that pocket. It's additional side material, but since it's recessed in an inch, the radius is a little bit smaller, so it had to get rebent. It's kind of got a curve, sort of a hook to it. It's more radiused on one side, and it sort of flattens out.
Yeah, it's kind of like you're building a guitar inside a guitar, but only about a tenth of a guitar inside a guitar.
Yeah, like a little tenth of a guitar inside there.
And believe me, we've actually seen a harp guitar with a smaller guitar inside it.
They do make one of those.
Somebody did, at least 100 years ago.
So here I am dry fitting again. This has to just get a lot of dry fit.
If I remember right, there's a lot of dry fitting going on in this section here, just to make sure everything got aligned perfectly and
is square to the top and his lengths are cut right. I'm using this template, which you can see only 6 tuner holes in that template, but in this build we're doing 7, so I'm actually just kind of accounting for that extra length on there just by eye and giving myself an extra, whatever inch worth of tuner pocket there. Yeah, this really is a cool design. I like how we're doing our tuner pocket, as opposed to like mounting some hardware on the outside of the body to have the tuners on it. You might as well just incorporate them into the body of the guitar.
I think aesthetically you end up with a lot nicer of a look and much more portable instrument, and it fits in a case a lot better. It also seems to lend itself to easy tuning and easy setup and design. And
the tuners are out of your way. They're over on the right side. You can use geared tuners. There's a lot of advantages to it.
Yeah, the tuners are on the back lower bout, so they're not in the way of your left hand positions on a classical guitar, which is something that classical guitars are trained to have certain techniques to access the high register of the guitar.
All right, last dry fit here. I think we finally got the pieces prepped and sanded flush and smooth, and I can just kind of get them right where they need to be. A couple little... Oh, I think I got a little more shaping to do on one of them. That's what I'm doing. I'm kind of marking the curve right there. There's that inside side is getting a little bit more curve. This is where it's kind of dangerous using that part of the sander there.
You said maybe during this section the block flipped out of your hands and came up and hit you in the forehead?
I remember it hitting me in the face, yeah. I think Tim must have cut that. Maybe he can find that. We'll put that in the bloopers at the end or something. You wouldn't have seen it because my head's kind of cut out of there, but it did hit me in the face. Okay, this is the last dry fit, I think. There we go. We're actually getting a little close up so you can see it. Oh, I got a little more trimming on that. One last trim.
Okay. Oh, you didn't like it.
I didn't like it.
Trim it off a little bit.
Trim off a little bit more.
One more dry fit.
So now there's enough of that side hanging over. You always want to leave a little bit of some material over the block so you can trim it off after it's glued. True it up. So I'm just now making, finally I think we're ready to assemble. I'm making the wedges, the shims for the neck, for the sides to go into the neck, and that shim goes in there and holds it in.
And this is a real particular method of neck joint. We're doing a Spanish heel neck joint, so what Dave is doing is making some tiny little wedges which will they will function as clamps to hold the side into that slot.
You'll see me tap them in right here. After that's in there, there's a little bit of a gap, left over, little space in that slot, and that wedge just fills in the gap. I always use that metal square to hammer them in.
Yeah, we've got a little...
Then you take a razor blade and
using the wrong tool
score
for
it.
that job, but it actually works pretty good.
Actually works pretty good, yeah.
It is just the right shape and weight and everything to do that job. So there is the first joint of the Spanish heel harp guitar neck.
Put in the treble side there. And we're getting close to the end of part 1 here, I believe. But yeah, this is just coming together really nicely. Everything about this build, we've done these several times now, but everything about this build really came together nicely.
We've built a lot of these instruments. These became, once Jamie Dupuis got a lot of that attention on YouTube, we became, this became a very popular model for us. We built a lot of them, and now Jamie has collaborated with us again on another one, and that's why we're doing this video series of the construction process. And now we've gotten really good at constructing these particular design harp guitars.
Yeah.
So
The super trebles.
Yeah, this build is coming along real nicely.
So yeah, thanks for tuning in, guys. Part 2 will be posted here shortly thereafter. So thanks for tuning in. Make sure you like and subscribe and share it out there to any of your guitar friends or builder friends. Check out our cool products. We got our hats and our mugs. Yeah.
T-shirts. We got a cool dad hat that my dad really likes to
Yeah.
wear. So yeah, if you guys want to support the channel and be an honorary Tonedevil Guitars rep, you can buy some products off our merch page at Tonedevil Guitars. And thank you guys so much for tuning into our channel.
All right, stay tuned for part 2.